Okay, now big R. The way that you define big R goes from the top of the figure to the axis of revolution. So big R would go from the top of the figure to the axis of revolution. So what would the height or the length of big R be? Square root of x, right. And it's still going to be top minus bottom. Okay, the top part is the square root of x. The bottom part is the x-axis, which is y equals 0, so square root of x minus 0. All right, little r is going to be basically the radius of the hole. Yeah, well, it can be any point in the hole because, yeah, it's always going to be the top minus the bottom. So if I kind of draw the little r right there, then it's the square root of x minus 0. If I drew little r right here, it's still the square root of x minus 0. I'm sorry, it's x squared. I'm getting cross-eyed over here. Yeah, so little r is going to be x squared. All right, and then all we have to do is plug it into the formula. So pi integral big R is root x, square it, minus little r is x squared, and square it, dx. And we'll be integrating from that x value to this x value, which this x value is obviously at the origin. And what is the x value of that point of intersection? It's 1, right. And you could use your calculator to find that. Or you can just know. Hopefully that was something that you could have come up with without a calculator, but if not, that's okay. All right, when you type that into your calculator, you get 3 pi over 10. And the biggest thing about the washer method is that you've got to take big R, the quantity squared, minus little r, the quantity squared. You can't do big minus r, the whole quantity squared. Okay. All right, number 4. Find the volume of the solid formed by revolving the region bounded by y equals x squared plus 1, y equals 0, x equals 0, and x equals 1. So we've got lots of graphs here. Y equals x squared plus 1 is a parabola that has been moved up 1. Y equals 0 is the x-axis. X equals 0 is the y-axis. And x equal 1 would look something like that. Okay, now what are we revolving this figure around? The y-axis. Okay, now when you revolve around the y-axis, the rectangle, this representative rectangle that we're talking about, needs to be perpendicular to the y-axis. So it's going to have to be right here. Is that a good place to draw it, or should I have drawn it somewhere else? That's fine. Okay, you are going to have to do 2. Okay, because if you draw it down here, you've got a right minus left, but up here, you have a different right minus left. Plus, yeah. Okay, think about dividing it into 2 parts. The bottom half is going to be completely solid, right? Because that axis of revolution completely butts up against that shaded green part. But the top part's going to have a hole in it. So what we're going to do is we're going to use the disk method on the bottom and the washer method on top. Okay, let me repeat that and see if you agree with it. If we had revolved it around the x-axis, we could have just done the disk method in one integral. Yes, she is correct about that. Okay, so let's do the disk method right here. The disk method, remember, is just pi big R squared. So what is R going to be? It's 1. Yeah, you're right, because R is going to be, big R is going to be the length of that rectangle right there. And if this is the line x equals 1, then we're going to, and this is the line x equals 0, right minus left is just going to be 1. Okay, so for the disk part, R equals 1. All right, so the volume would be pi integral of 1. What's my variable of integration? dy. Yeah, you do. Technically, you do. Okay. You do need to square the 1. All right, now what are my limits of integration going to be? Okay, is it this 0 to 1 down here on the x-axis? No, it's the 0 to 1 on the y-axis right here. Okay, this ends up being, is it pi? Yes, it would be pi. Okay, let me switch colors for the washer method. Okay, for the washer, we need a big R and we need a little r. Big R is from the axis of revolution to the very outer part of the figure. So that would equal 1. And little r is the radius of the hole. So what's the length of little r? Right minus left. Okay, it's the square root of y minus 1, because when you do right minus left, you have to solve your equations for x. And it's going to be the positive one. What are our limits of integration going to be? 1 to 2, right? This is the point 1 comma 2. So our lowest y value is 1, the upper y value is 2. Okay, big R squared would be 1 squared minus little r squared would be the square root of y minus 1 squared dy. Whoops, I don't need the equal sign right there. And that is pi over 2. Sure, you're more than welcome to simplify as you go. Like, are you talking about when you put this into the equation doing just y minus 1 so you don't have to square the square root? That's fine. All right, so the bottom part was pi. The top part was pi over 2. So the total volume is 3 pi over 2. Okay, we're going to skip number 5 and go on to number 6. All right, let R be the region bounded by the x-axis, the graph of root x, and the line x equal 4. All right, so root x, the x-axis, and x equal 4. What is this point of intersection right here? 4, 2. I don't know if we need that, but I just felt the need to put it down. Okay, A, find the area of region R. This is a good quiz review. All right, on your own, write out the integral and use your calculator to find the area of A. And you could use a horizontal or a vertical rectangle. Doesn't really matter. I would probably use vertical, personally. Okay, 16/3. All right, find the value of h such that the vertical line, x equals h, divides the region R into two regions of equal area. Okay, everybody okay with part B? Did you get it in your calculator? Okay. I guess technically the calculator is going to make you put parentheses around this root x also. So don't let that throw you off. Okay, C. Find the volume of the solid generated when R is revolved around the x-axis. Disk or washer? Disk, okay, because we'll have no hole. That axis of revolution completely butts up against your figure right there. Okay, so how am I going to set up the integral? It's going to be pi, what to what? 0 to 4, root x squared. Yeah. Pi integral big R squared. And you get 8 pi. Okay, so find the vertical line x equal k so that I'm dividing R into two regions such that when the two regions are revolved around the x-axis, they generate solids with equal volumes. Okay, so it's basically the same thing as the equal areas. How would I do this? 4 pi equals pi integral from 0 to k root x squared dx. When you're typing that into your calculator, I would knock the pi's off of that because you've got a pi on both sides. It just kind of clutters things up less. But you should have gotten k equals either root 8 or 2.828. Okay, I'm going to tack one more on here. I want to take this figure and let's revolve. Let's revolve around the line y equals 3. So is this going to be a disk or a washer? Obviously a washer. All right, now big R is from the axis to the very far outer part of your figure, which would be 3. It's always top minus bottom. That's why I wanted to do the axis of revolution up above the figure, because the length of R is always going to be top minus bottom, or right minus left. So big R is 3. All right, what would little r be? Is it the square root of x minus 3? 3 minus the square root of x. R is the radius of the hole, and the length of R, you have to do top minus bottom. If you do bottom minus top, you're likely to basically get a negative answer. All right, so the formula would be pi, still the integral between 0 and 4. Big R squared is 3 squared minus little r is the quantity 3 minus root x squared. Dx. We think the answer is 24 pi.